Imagine waking up one morning and realizing you have never actually seen the world. You have only seen electrical signals. The colors you trust are interpretations. The sounds you hear are translations. The people you love exist inside a 3-pound organ made of fat, water, and electricity. You do not live in reality. You live in a model of reality, constructed moment by moment by your brain. Right now, trillions of chemical reactions are firing inside your head, not randomly, not blindly, but with astonishing precision, faster than any computer humanity has ever built. And from this storm of chemistry emerges something impossible: a thought, a memory, a dream, a fear, a decision, a self. You call it I. But what exactly is that I? Where does it come from? Why does matter become aware of itself? Tonight, we take a journey into the deepest mystery known to science. Not black holes, not the beginning of the universe, but the thing reading these words right now, the human brain and consciousness. Hold your hand up in front of your eyes. The shape feels simple, familiar, ordinary. Yet to recognize that single hand, your brain must solve a problem more complex than launching a spacecraft. Light particles bounce off your skin and enter the retina. There, specialized photoreceptors convert photons into electrical impulses, not images, not color, not meaning, only voltage changes. At this stage, your brain does not know what a hand is. It only receives contrast, edges, movement. The visual cortex begins assembling fragments like a puzzle that has no reference picture. Lines become contours. Contours become shapes. Shapes become objects. Objects become your hand. All of this occurs in less than half a second. The human brain contains approximately 86 billion neurons. Each neuron forms thousands of synaptic connections. Altogether, the brain forms an estimated 100 trillion synapses, a network so vast that if each connection were a road, it would exceed the total distance across the observable universe. And yet this structure fits in the palm of your hand. Every second, electrical impulses travel through neural circuits at speeds up to 120 meters per second. But speed alone does not explain intelligence. The brain's true power lies in parallel processing. Millions of specialized regions work simultaneously. The occipital lobe analyzes vision. The temporal lobe interprets sound and language. The parietal lobe maps space and body position. The frontal lobe plans actions and simulates the future. No central screen exists where everything is displayed. No inner observer watches a projection. Instead, awareness emerges from coordinated activity, like a city whose life exists not in one building but in the relationships between all buildings. You never feel most of these processes. Your brain filters approximately 99.999% of incoming sensory data before you become aware of it. Your eyes alone detect roughly 10 million bits of information per second. Your conscious awareness processes about 40 to 50 bits. If all sensory data reached awareness, the world would not appear vivid. It would appear chaotic, unusable. So the brain compresses reality. It removes constant background noise. It stabilizes the shaking caused by eye movement. It fills blind spots where no receptors exist. It predicts missing details before you notice they were absent. In fact, a portion of what you see never reached your eyes at all. The brain simply assumes it should be there. Consider reading this sentence. Your eyes jump in rapid movements called saccades several times per second. During each movement, you are effectively blind for a fraction of time, yet you experience a continuous image. Your brain edits the gaps. Reality, as experienced, is not raw input. It is processed output. You do not perceive the world directly. You perceive the brain's best guess. Consciousness, therefore, is not full awareness. It is selective awareness. For most of human history, we believed perception worked like a camera. The world happens first, then the brain records it. Modern neuroscience shows the reverse. The brain does not wait for reality. It anticipates reality. At every moment, your brain generates a model of what it expects to exist one fraction of a second into the future. Incoming sensory signals are then compared against that prediction. Only the differences, the errors, are forwarded into awareness. This system is called predictive processing, and it completely changes what it means to experience the world. You are not seeing the present moment. You are seeing your brain's prediction of the present moment, corrected just enough to remain useful. Imagine walking into your bedroom at night. You do not analyze every object again. You already know where the bed is, where the door is, where the floor begins. Your brain renders the room instantly using memory. Vision merely confirms it. If prediction dominates perception, then illusions become understandable. Optical illusions are not failures of vision. They are moments when prediction overpowers correction. For example, in the famous checker shadow illusion, two squares with identical brightness appear different because the brain predicts lighting conditions and adjusts color automatically. Your brain prioritizes meaning over accuracy. Another example, when someone speaks, your brain predicts upcoming words based on grammar and experience. That is why you can understand a sentence, even if parts are distorted by noise. You are hearing partly with your ears and partly with memory. Even touch follows prediction. You cannot tickle yourself because the brain predicts the sensation and cancels the signal before it reaches awareness. Unexpected touch feels stronger than identical expected touch. Pain, too, is influenced by expectation. Athletes often continue running on injuries they only feel after the race ends. The brain suppresses signals that conflict with immediate goals, then releases them once safety is achieved. Perception is therefore negotiation, not recording. The brain constantly asks, what do I expect? What actually happened? What must I update to survive? Your experienced world is the compromise between these answers. In a strict sense, every human lives inside a controlled hallucination, a simulation constrained by sensory evidence. Reality is not delivered to you, it is constructed by you. We trust memory because it feels solid, because it feels stored, because it feels like a recording. We can replay, but the brain does not store the past like a video file. It stores fragments, then rebuilds the story each time you remember. When an event occurs, the hippocampus rapidly links separate elements: the place, the faces, the emotions, the meaning. These are distributed across different regions of the brain. Memory is not kept in one location. It is a pattern across many networks. Later, when you recall the event, the brain reactivates those networks and reconstructs the experience, not retrieves it, recreates it. And during reconstruction, the present moment interferes. Your current beliefs reshape interpretation. Your current emotions alter intensity. Your current knowledge fills missing details. After recall, the memory is stored again, but now slightly changed. This process is called reconsolidation. So every remembering is also editing. This explains why siblings remember the same childhood differently, why people argue over events they both experienced, why certainty increases even as accuracy decreases. The brain values usefulness over precision. Experiments show how easily memory can be rewritten. Participants shown altered photographs later remember events that never occurred. People confidently recall words never spoken if they fit the story context. They are not lying. The brain completed a pattern. Emotion strengthens this effect. Adrenaline marks memories as important, but it does not protect accuracy. It protects significance. You remember how it felt more reliably than what actually happened. Trauma demonstrates this clearly. Painful memories replay vividly yet change over time, not because they fade, but because the brain keeps trying to interpret them differently to achieve closure. Forgetting is not a failure. It is a function. Without forgetting, the mind would be overwhelmed by irrelevant detail. The brain prunes information to preserve meaning. Your past, therefore, exists as a living narrative, continuously rewritten to support identity. You are not the person who experienced those moments. You are the author interpreting them now. You feel like a single, unified person inside your head, a central decision maker watching, choosing, controlling. Neuroscience suggests something far stranger. The brain is not one mind. It is a coalition of many specialized systems operating simultaneously. Perception systems, emotional systems, habit systems, language systems, motor systems, each solving its own problem. Yet your experience feels unified. Where does this unity come from? Split brain research revealed the answer. In certain epilepsy treatments, surgeons severed the corpus callosum, the bundle connecting the left and right hemispheres. After surgery, both halves could still see, learn, and act, but they no longer shared information directly. When researchers presented an image only to the right hemisphere, the patient could not verbally name it. Language lives primarily in the left hemisphere, but the left hand, controlled by the right hemisphere, could select the correct object. Then something remarkable happened. When asked why the hand chose that object, the speaking left hemisphere invented a reason. Not because it knew, because it needed coherence. The brain produced an explanation after the action occurred. This mechanism is called the interpreter. It continuously builds a story that makes behavior appear intentional and unified. Your sense of self may be this story. Further experiments support this. In Benjamin Libet's famous readiness potential studies, measurable brain activity predicting a movement appeared hundreds of milliseconds before participants reported deciding to move. The action began unconsciously, awareness followed. Later studies using brain imaging extended this window to several seconds. Your brain commits to actions long before the conscious narrative claims authorship. This does not mean you are powerless. It means the role of consciousness is different than assumed. Instead of initiating behavior, consciousness may monitor and veto it. The frontal cortex can cancel an action at the last moment, a free won't rather than free will. Consider everyday experience. A thought appears uninvited, an emotion arises automatically, an impulse urges action. You did not create the impulse, but you can allow or restrain it. The self, then, is not the origin of every mental event. It is the regulator, the narrative layer organizing many underlying processes into a stable identity across time. You are less like a king giving orders, and more like a parliament negotiating outcomes while a narrator writes the history afterward. Neuroscience can explain how signals move. It can map networks. It can predict decisions. But one question remains untouched by measurement. Why does any of this feel like something? Electrical activity flows through your brain every second, yet only some of it becomes experience. Most neural processing happens silently with no awareness at all. So why do certain processes become a calm? Panicked by color, sound, emotion, and meaning. This is known as the hard problem of consciousness, not how the brain works, but why it is experienced. A computer camera detects wavelength 700 nanometers. Your brain experiences red. Physics can describe the wavelength. Biology can describe the receptors, but neither explains the sensation itself, the redness of red. This inner quality is called qualia, the raw feeling of experience, the taste of sweetness, the ache of nostalgia, the warmth of sunlight on skin. Science can correlate them with neural patterns, but correlation is not explanation. Several major theories attempt to answer this mystery. The first proposes emergence. When information processing becomes sufficiently complex and integrated, awareness naturally appears, like liquidity emerging from molecules that individually are not wet. This idea is supported by integrated information theory, which suggests consciousness corresponds to how unified and interdependent a system's information is. Another perspective suggests consciousness is a global broadcast. According to global workspace theory, many unconscious processes compete, and the winner is broadcast across the brain, becoming conscious so multiple systems can coordinate behavior. Consciousness, in this view, is the brain's coordination interface. A third possibility is more radical. Instead of consciousness arising from matter, matter may exist within consciousness. Some physicists and philosophers propose that awareness is a fundamental property of reality, like mass or time, and brains function as receivers or filters rather than producers. In this interpretation, the brain does not create experience. It limits it into a usable perspective, much like a radio tunes a wide electromagnetic field into a single song. We do not yet know which explanation is correct. Perhaps none are complete. But one fact remains clear. The universe has produced structures that not only process information, but feel the existence of information. Atoms follow laws. Life follows needs. Mind follows meaning. Consciousness is where physical processes, become presence. We assume time flows at a constant speed. Clocks suggest uniformity. Experience does not. Moments of danger stretch into slow motion. Hours of routine vanish without trace. The brain is not measuring time, it is constructing it. Neuroscience shows there is no single internal clock. Instead, multiple systems estimate duration based on change, attention, and memory density. When events are novel, the brain records more detail, more neural activity is stored. Later, when recalled, the interval appears longer because more information exists inside it. When events are repetitive, prediction replaces processing. Less information is stored, the brain compresses the period, and life seems to accelerate. This explains a universal experience. Childhood feels expansive because everything is new. Adulthood feels fast because most days are predicted before they occur. Dopamine also alters time perception. High dopamine states, curiosity, exploration, anticipation, increase temporal resolution. You notice more micro-events per second. Time feels rich and extended. Low engagement states reduce sampling of experience. The brain skips detail to conserve energy. Time collapses into vague continuity. Even the present moment is delayed. Sensory signals require tens to hundreds of milliseconds to reach awareness. The brain compensates by predicting slightly ahead so actions remain accurate. You are always living in a constructed present, a best estimate synchronized with reality rather than a direct reading of it. Your sense of life length, therefore, depends less on years lived and more on memories formed. A year full of novelty contains more experienced time than a decade of repetition. You do not lengthen life by counting days. You lengthen life by increasing conscious moments. We often describe emotion as the enemy of reason, as noise interfering with clear thinking. The brain does not agree. Emotion is not a disruption of intelligence. It is the foundation of decision making. Every choice requires value, and value is assigned by emotional systems long before logic explains it. Deep within the brain, structures such as the amygdala, insula, and ventromedial prefrontal cortex continuously evaluate incoming information. They ask a simple question: is this good for survival or dangerous for survival? This evaluation happens in milliseconds before conscious thought begins. Patients with damage to emotional centers provide powerful evidence. They can reason perfectly, calculate probabilities, and analyze outcomes, yet cannot choose between simple options like appointment dates or meal selections. Because logic compares possibilities, emotion ranks importance. Without emotional weighting, every option remains equal. Decision collapses into endless analysis. Fear narrows attention toward threat. Disgust prevents contamination. Attachment protects relationships. Curiosity drives learning. Even morality is emotionally grounded. People feel harm before they reason about harm. The explanation follows the reaction. Emotion also shapes memory. Events paired with strong feeling are prioritized for storage because the brain assumes emotional intensity predicts future relevance. But emotion does not only react, it predicts. Your mood today changes what you perceive tomorrow. An anxious brain detects danger faster. A calm brain detects opportunity faster. You do not see the world first and then feel about it. You feel first and then perceive accordingly. Reason is the advisor, emotion is the vote. If the brain predicts decisions before awareness, do we truly choose? This question has unsettled philosophers for centuries and neuroscientists for decades. In laboratory experiments, participants were asked to press a button whenever they felt the urge. While they waited, electrodes measured brain activity. A pattern consistently appeared. Neural preparation, called the readiness potential, began hundreds of milliseconds before the person reported deciding. The brain moved first. The conscious decision arrived later. More advanced imaging later extended this gap to several seconds in some cases. Researchers could predict which option a participant would select before the participant became aware of choosing. At first glance, this seems to eliminate free will entirely. But the deeper interpretation is more subtle. The brain generates possibilities continuously, impulses, thoughts, tendencies, shaped by genetics, memory, emotion, and environment. These arise automatically, outside conscious authorship. However, consciousness possesses a rent capability, not initiation. but intervention. Experiments show participants can cancel a movement in the final fraction of a second after the readiness potential begins. The action is prepared unconsciously, yet consciously vetoed. This is sometimes called free won't. You may not choose the first thought that appears, but you can choose whether it becomes behavior. In daily life, this is familiar. Anger arises. You pause. Fear urges avoidance. You step forward. Desire tempts impulse. You restrain it. The initial signal was automatic. The response was not. Free will may therefore operate not as a creator of impulses, but as a regulator of them, a supervisory system that shapes long-term patterns by repeatedly allowing or refusing actions. Over time, vetoes rewire habits. Repeated approval strengthens them. You do not control every moment. You influence the trajectory. Freedom exists less in single choices, and more in consistent awareness applied across many moments. For much of history, scientists believed the adult brain was fixed. You were born with a structure, and slowly lost parts of it over time. Modern neuroscience revealed the opposite. The brain is not static tissue, it is adaptive architecture. This property is called neuroplasticity, the ability of neural connections to reorganize in response to experience. Every thought activates a specific network of neurons. When that network fires repeatedly, synapses strengthen through biochemical changes, receptors increase, signal transmission becomes faster, and pathways require less energy to activate again. Neurons that fire together wire together. Habits therefore become physical structure. Not metaphorically, literally. A pianist shows enlarged motor cortex regions controlling finger movement. A taxi driver navigating complex streets shows increased hippocampal spatial mapping volume. A person practicing worry strengthens threat detection circuits. A person practicing gratitude strengthens regulation circuits in the prefrontal cortex. Attention acts like a sculptor's chisel. What you repeatedly notice becomes easier to notice again. The brain is constantly asking, which pathways should become automatic, which should fade to save energy? Unused connections weaken in a process called synaptic pruning. The brain removes inefficient routes to optimize performance. This is why behaviors grow easier with repetition, and why change feels difficult at first. You are not only resisting psychology, you are resisting existing wiring, but plasticity works both ways. New patterns, repeated consistently, eventually require less effort than old ones. Over weeks and months, conscious effort becomes unconscious tendency. Your personality is not only inherited, it is accumulated. Every reaction trains the system predicting future reactions. Every focus trains the system detecting future meaning. You are not only experiencing the world, you are building the organ that will experience tomorrow's world. When you fall asleep, consciousness fades, but brain activity does not stop. It reorganizes. Sleep is not shut down. It is scheduled maintenance for the mind. During deep sleep, a network called the glymphatic system becomes highly active. Cerebrospinal fluid flows between brain cells, washing away metabolic waste produced during waking hours. Among these wastes, proteins associated with neurodegenerative diseases when accumulated over years. While awake, neurons work intensely and produce byproducts. During sleep, the brain physically clears them. You wake not only rested, but biologically reset. Memory also undergoes processing. The hippocampus temporarily stores daily experiences like a short-term buffer. During sleep, especially slow-wave and REM stages, these patterns replay in compressed form. The cortex integrates them into long-term storage and extracts meaning. You do not simply remember after sleep, you understand better after sleep. Dreaming appears to combine emotional regulation with simulation. Threatening scenarios are rehearsed in a safe environment. Unresolved emotions are reprocessed without the full intensity of waking chemistry. The brain reduces emotional charge while preserving informational value. Sleep deprivation reveals how essential this is. Without sleep, attention fragments, perception destabilizes, and emotional reactions intensify. The boundary between imagination and reality weakens because predictive systems lose calibration. After extended wakefulness, the brain briefly enters micro-dream states while awake. hallucinations generated by exhausted predictive networks. Sleep, therefore, is not the opposite of consciousness. It is the condition that preserves coherent consciousness. Identity depends on nightly reconstruction. Without it, memory disconnects from meaning and perception disconnects from stability. Each night, the brain edits yesterday so tomorrow can make sense. Most of the time, the brain maintains a stable sense of self, a continuous narrative linking past, present, and future. This stability is supported by a network called the default mode network, active when attention turns inward toward memories, plans, and identity. But under certain conditions, this network quiets in deep meditation, sensory deprivation, intense flow states, or psychedelic research settings. Activity in self-referential regions decreases while sensory integration regions remain active. People consistently report similar experiences. The boundary between observer and world weakens. Thoughts continue, but no longer feel owned. Perception becomes vivid yet impersonal. Time feels expanded or absent. This suggests the sense of I is not required for awareness itself. It is an added layer, a model the brain maintains for prediction and social interaction. Normally, the brain compresses experience into a narrative. This is happening to me. I am thinking this thought. I am located behind my eyes. When the narrative system reduces activity, awareness remains, but identification loosens. Perception occurs without the usual tagging of ownership. Neuroscientifically, this may represent a shift from top-down prediction to bottom-up sensory processing. Fewer assumptions, more raw input. The brain is still functioning, but the story about the thinker fades. These states reveal something important. Consciousness is not identical to the self. The self is a mode. Consciousness can enter. Just as vision can focus or blur, identity can intensify or soften. Your everyday personality is not the permanent center of awareness. It is the brain's most useful configuration for navigating society and survival. At the edge of awareness, the narrator grows quiet, yet experi. NCE continues. All brain activity we have discussed, perception, memory, identity, prediction, depends on organized electrical patterns across neural networks. At death, these patterns do not vanish instantly. They dissolve in stages. As oxygen supply drops, neurons lose the energy required to maintain electrical gradients. Communication becomes unstable. Senses fade. The narrative self weakens. Yet measurements in clinical settings have revealed a surprising phenomenon. In the final moments after cardiac arrest, some brains exhibit a brief surge of highly synchronized gamma activity, frequencies associated during life with attention, integration, and vivid awareness. The brain, in its last organized act, may enter a state resembling intensified consciousness. We cannot know the experience itself. Only the signal. Science can record patterns, but subjective awareness remains private to the one undergoing it. Near-death reports across cultures share recurring features: loss of body boundaries, panoramic memory recall, altered time perception, a sense of clarity or detachment. These reports do not prove what occurs after death, but they demonstrate how the brain behaves when its predictive models collapse and normal sensory input ceases. Without external reference, the mind turns inward, generating experience from stored structure alone. Death therefore raises the deepest question in neuroscience. If consciousness depends on brain organization, what is lost when that organization ends? The process, the experience, or only the interface through which experience was expressed? We do not yet have an answer. But we know this: the same system that constructs the world also constructs the sense of existing within it. The atoms in your brain were forged inside ancient stars. For billions of years they drifted, unconscious, through space and stone and ocean. Now they think, now they question, now they wonder what they are. The universe has organized itself into a structure capable of asking why it exists. You are not merely in the universe is becoming aware through you. Every perception is reality examining itself. Every thought is matter reflecting on its own existence. And perhaps consciousness is not something you possess. Perhaps it is something you participate in. The brain is finite, but awareness feels infinite. Inside your skull is darkness and electricity. Yet inside your experience, there is a world, And the greatest mystery of all is this: the brain studies the universe, but the universe studies itself through the brain.